Hi, my name is Arturo Silva. We developed a notebook for modeling CO2 sequestration globally, and CEO of Quantum Works, which is a company, consulting company on mathematical issues. Thank you very much for coming to this talk on carbon sequestration and storage. I need to begin with full disclosure. We set up a very ambitious goal to try and simulate the capture of CO2 in the whole atmosphere. And as we used up several gigabytes of data, we started dialing down the resolution and the actual network for the simulation of the amount of carbon sequestration facilities as projected by the number of sites where the CO2 is being generated. We actually couldn't handle the whole project, no. So we settled on using Wolfram's capabilities. We used a very large computer at UNAM in Mexico, and it actually couldn't handle that amount of calculation and memory. So that's before I begin. My apologies for that. But we at least got to use Wolfram language for displaying and showing the data, the geolocation of the data, and we found some very interesting features of the distribution of CO2 on planet Earth, as well as the distribution of sequestration facilities which are in actual use. So that's where we'll focus our attention on. So we began by using this data, which is publicly available. There's a whole bunch of sites on the internet where you can download the data on CO2. There's the IPCC, which is probably the best and most curated place for it. And there you can find data from 1972 to 2000, and 2012 actually, 2019, which is this year. So it's several years, about 40 years of data that they have available. So we import this data, we generate the data from the coordinates. The data corresponds to latitude, longitude, and CO2 concentration. And it's normalized by year so that you can actually see the actual amount of CO2 as a percentage of the total. And this is one of the images we got. We can see here that it's mainly on land, of course, but we can see all the also the CO2 generated by transportation on the seas, no, and transportation sea routes globally. Another issue that we found interesting is that the main, according to this data, the main generation of CO2 is in Asia, mostly in India and China. And also a huge increase has been detected on Africa. This picture is normalized to show the amount as percentage increase. We also use these capabilities to show the geoposition of the places where there are the most emissions of CO2. That's the red dots. This is over a gigabyte of data, which is summarized here. And here we count the top 10 sites where the CO2 concentration is greatest. And as we said, it's mainly on China, India, and this part of Africa where we can find these concentrations. There's also the countries, no? If we go by resolution of countries where these emissions are greatest, we can see that China and India are a big generation. One of the issues with this fact is that carbon emissions will only rise, you know, in the future. So it's a big concern to have carbon sequestration facilities distributed with some kind of logic. You know? Later, we're going to see the actual places where carbon sequestration facilities are located. Here we can see again, a normalized version of hotspots of CO2 intensity activity. And this is another view with this Olbers projection. Again,
excuse me, when you say
sure.
intensity or activity, is this the increase over time or is it the concentration that you're talking about?
It is the concentration in the last year.
Not per capita either.
Per year, yes. So that's the concentration using the data from 2018. I'm sorry?
That's given in parts per million.
Yes, parts per million. Yeah, it's about 400 parts per million.
What is the difference between the highest and the lowest values here?
I'm sorry?
What is the difference between the highest and the lowest values you measure on your maps?
Yeah, it's we have the range over here. So I can show you the difference in concentration. I think there is a scale over here. Let me see now. We can check that really quickly.
You can check later.
Yeah, sorry.
It looks like we're sitting on top of one of the hotspots.
Right now?
Yeah.
Yeah,
Champaign.
in Champaign, Illinois. Yeah. This is the actual distribution of CO2 sequestration facilities. Let me show you that. So here there's a database of the facilities available for carbon sequestration globally. They're mainly concentrated in the US and Canada. Here's where the tar sands are done.
Facilities? Or
Yes, facilities which are currently working.
What's the unit here on the right side?
Number, that's a count of facilities. There's a lot of in California and in Texas. There's virtually none in Latin America. There are some in China and in India. There's in Australia. There's a few in Canada also. And yeah, this is a global problem, but there's some in the Arabian Peninsula. Even though it's a global problem, it's currently not as treated as it should. No? This also due to the fact that these are expensive facilities. No, it's here we made a plot with the different kinds of carbon sequestration facilities there are. For instance, there is a threshold for which power absorption, CO2 absorption is achieved. That's why it's mainly located where the power is being generated rather than just spread all over. Just last week, there was an article published by MIT where there's a new technology that's being researched on that captures CO2 at low concentrations, but that's still as a development technology. It's not widely used. Right now, one of the problems with these facilities is the fact that they require energy to be used. No? So they sit side by side with power generation facilities. No? So they mitigate the issue, but that's why here are some. It's classified as power distribution. Some of them use carbon, coal. This is the distribution of these technologies, mainly in North America and in the United Kingdom. And also there's some industrial sites which are more widely spread in the world. And this is just carbon capture and sequestration, mainly in oil states, in Texas and in Canada, mostly. And this is direct air capture, which, as we said, it's just sequestration of CO2 directly from the atmosphere, regardless of where the concentration is big enough to be sequestered. One of the issues also is the fact that you need to store this CO2 in the ground so it doesn't filter out to the atmosphere again. Otherwise, you're just shifting the problem away. No? If it leaks out in 200 years, then you're going to have an issue in 200 years' time. No? So it's that's why the geological location is also critical. I mean, it's not just put it wherever there is a source of CO2. You have to consider the ground on which this facility is located, and make sure that it's appropriate for it to store the CO2, which has been captured, and it remains there for the longest time possible. Because leakage, even if it's 1% per year, it's going to be an issue. Yes.
Where does EOR fit in these categories?
The what? Sorry.
Enhanced oil recovery.
Enhanced oil.
Carbon dioxide.
On you mean on the sea?
In those categories you have for your map, where does that fit?
I'm sorry. Which? In these categories?
Yeah. Which of those categories would include enhanced oil recovery operations?
Okay. As far as I know, that's not included in these categories, in this database. Okay.
Excuse me, have you
Sure.
any data on the individual capacity of each of those sequestration facilities, or are they all the same size?
No, they're different in size. Yeah, it's some tons per year. It's actually some megatons per year. But the website, there's each of these has a very specific. Let me see here. Each of these has a very specific capability, and it's all shown in each individual side of it. So it varies a lot.
Do you have a feel
Between.
for what percentage of production is being recovered? I assume it's a fraction of 1%?
Yes, it's a fraction of 1%. It's about 0.03. Yeah. Yeah, it's we need about 3,000 times the actual installed capacity to mitigate the with current technology. I mean, it's in the order of thousands of times what we currently have installed to actually have some impact. Even if we have carbon neutral emissions, there is an impact of at least 500 years in the climate. I mean, if we stopped the emissions of CO2 today, for some magical reason, still the impact of this in the long term is already being done because of the heating of the ocean and the interchange with the atmosphere. So it's a big effort, but again, the economic consequences of status quo it has a bigger impact, even in the short term, than just doing nothing, the business as usual scenario. So basically, that's the material I wanted to share with you, and I'd like to know if you have any further questions. Or sure.
Is there an economically viable way to recover carbon at this point? In other words, are there businesses that are doing this that are basically financially stable, or is this something that governments are doing? Or?
Yeah, it's the short answer is no. It's not a business. I mean, it should be offset by I don't know, tax incentives and policy that really helps mitigate. The political vision of this, it's very important because it has some major impact on the actual practices that take place. So, no problem. Sure. Yeah.
So far, it's still at a loss, but it's improving pretty quickly. Governments are being able to put money into it too.
Yeah, but if you think about it, it's actual economic activity that's being promoted by these. It's infrastructure projects that have a positive impact. Even though it costs money, it generates revenue as well.
Hopefully there's no incentive to use more carbon as a result.
Yeah. Otherwise, the purpose is defeated.
Yeah.
You're using it, you're sequestering it, but you're getting more. Are you familiar with the projects near here? There's within an hour distance, there's a couple big
No.
sequestration projects.
Is there also a large source of CO2 here? Because it was
Yes,
applied on the map.
Yeah.
Down in Decatur is the DDM Biofuels ethanol plant. So we've been capturing carbon from that for the last 8 years. And there's actually 2 projects on their property down there. One of them was a research project that injected 1 million tons, and the other one is still ongoing. It's a total goal of 5.5 million tons.
Yeah, all these
Just
projects.
right here.
all these projects are in that order of magnitude of gigatons.
You showed a
useful
slide
life.
at the beginning
Yes.
where there was traffic over the oceans.
Oh, yes.
A lot of those weren't almost perfect circle routes. I'm wondering if that included aircraft as well as seafaring vessels.
It probably does,
Yeah, okay.
because it's too dense
Yeah,
to
yeah.
be only seafarers. Yeah, but it's interesting to note that the human activity is just shown very clearly there.
Can I find cows on there?
Not on the sea, just occasionally.
These striations, the streaks, are those from airliner flights measuring CO2?
Yeah, that's what we were saying here, that it's
Are they taking
maritime.
measurements at ocean level from boats that gives a little darker blue, or how do we know what the measurement is there?
No, as far as I know, these are satellite measurements.
You mentioned you ran out of compute power.
Yes.
I was wondering if you had considered using AWS.
No, we haven't. We used a supercomputer in UNAM in Mexico, in Querétaro,
Was
which
it
is
a
used for,
memory problem?
yes.
Or- yeah, okay.
yes, it was, we needed several more terabytes in RAM
RAM,
to achieve this
yeah.
goal. But we could also just diminish the resolution.
Right.
And but then we didn't really have other than the obvious result, which is put it right next to the. I mean, we wanted to to the source.
Yeah.
We wanted to have a network, but it never showed. With the resolution was so low that it only gave the trivial solution of placing on top of the sources. So that's why we didn't achieve the original goal, which was to have a network effect.
It also sounded like there were certain geological
Yeah.
characteristics
Yeah.
that were important in being able to do this. Right?
Yeah.
So,
That's right. So we need to match both,
Yeah.
geological and atmospheric, and have a network effect, but that we couldn't achieve. Not at the moment.
Do you know
Sure.
what's contributing to the large concentration south of Florida?
That's a good question. There's also a large, to be honest, I don't know. There's also a very large concentration in Central America for some reason. I mean, it's not heavily industrial, and it's also not heavily oil producer, but there is really as large as in Mexico or higher, which is puzzling, because there's really, as far as we know, not much going on there as far as CO2 emissions, but apparently there is some issue going on. But China and India are really not surprising.
I would also imagine agricultural practices play into that.
Definitely, yeah. But cattle and, no, not real cattle, that's methane. Methane, but yeah, probably. Okay. Are there any other comments? These data and the notebook are, of course, available if you wish.
Thanks.
So, if there's nothing else, just. Sure.
Research project
No, it's really not a research project. It was not intended to as such. It was just something we collaborated with on some researchers with at UNAM and my company in Mexico, which is QuantumWorks. We do algorithm design for companies. So this is just something we try to put together.
Will you continue
Sorry.
developing?
Yes, definitely. Yeah, we're on that path. Yep. Yeah, it's worth working on it.
Yeah.
But we need more resources. I mean,
I was going to ask, how do you get all the geologic data for the
The-
entire world? That's a lot.
yeah, but there is just in our research facility in Mexico, There is a physics, applied physics center right next to a geological research center. So we haven't, I'm in the research, well, I collaborate with the physics department, but not with the geophysics or the geology. So we just need to have a conversation and just make that happen. But we're on our path to achieve that. Yeah. Okay. Well, thank you very much.